From our last lecture in arithmetic progression, we now know what is a term in an AP, what is the first term, what is the common difference, last term, infinite AP, finite AP, etc. Today, let's see what do we need, the minimum amount of information that we need to know an AP. Let's say I give you the first term A, and I also give you the common difference D. Then can we tell what is the AP? Yes, we can. The first term will be A. The second term, we just add the common difference to it, A plus D. The third term, A plus 2D. The fourth term, A plus 3D. The fifth term, A plus 4D, and so on. So this is a sufficient information if we know the first term and we know the common difference. For example, let's say I give you A as 3 and D as -1. Then we start with 3, 3 minus 1, 2, 2 minus 1, 1, 1 minus 1, 0, -1, and so on. You can think of many such examples. Now, what about other way around? If we know the list of numbers, can we find the first term common difference? For example, if we have a list of numbers like 6, 9, 12, 15, 18, and so on. So yes, our first term will just directly be the first term, A is 6. Now, in order to find the common difference, we can just take any two consecutive numbers and subtract the number at the higher position from the one preceding it. So D can be either, let's say, so this is T1, this is T2, this is T3, this is T4, T5. So D can be either T5 minus T4, that is 18 minus 15 is equal to 3, or it can also be T3 minus T2, 9 minus 6 is equal to 3, or T4 minus T3, that is equal to 15 minus 12 is equal to 3. So we can take any such two consecutive numbers. But always remember that we need to subtract a term at lower position from the term at one position higher than that. T5 minus T4, T3 minus T2, something like that. So be careful that if we have something like 6, 3, 0, minus 3, minus 6, something like that, then if you want to find D, then you have to subtract 3 from 6, that is 3 minus 6 equal to -3, and not 6 minus 3 is equal to 3. This would be wrong. So you always have to subtract from one position higher to lower. So we'll 0 minus 3 minus 3, or -6 minus -3 equal to -3. So in general, the common difference D will always be equal to D k plus 1, that is k plus 1 term minus tk. Let us have a look at an example. For example, if we have an AP for an arithmetic progression, 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2. We need to find the first term and the common difference. So A would be 3 by 2, and for common difference, we can take any two terms, minus 1 by 2, minus 1 by 2. So this minus this will be equal to minus 2 by 2 minus 1. Or we could also have done 1 by 2 minus 3 by 2. Minus 2 by 2 will be -1. Let us have a look at one more example. We need to find if these sequences are in an AP. Start here. What do we have as a difference here? 10 minus 4 is 6, 16 minus 10 is 6, 22 minus 16 is 6. So the common difference remains constant. So it is an AP. Here, -1 is -1, -2, -3, -1, -2. we have minus 2, minus 2, minus 5, minus minus 3, minus 2. So this is an AP. Let's say in this case 2 minus of minus 2, this will be 4, whereas minus 2 minus 2, it will be minus 4. 2 minus of minus 2, this is 4. So the fixed difference is changing. Here we have 4, here we have minus 4, here we have 4 again. So this is not an AP. Whereas here we have 0, 1 minus 1, 0, 2 minus 1, 1. So the fixed difference is changing. So this is again not an AP. So this we should keep in mind. So always we should keep this in mind, that the succeeding terms in an AP is always obtained by adding a fixed number to its preceding term. The fixed number can be positive, negative, or 0.